prove by contradiction that if n squared is a multiple of 3, n is a multiple of 3. So we start with the negation and write down the assumption. Assume that there exists a number n such that n squared is a multiple of 3, but n is not a multiple of 3. And any multiple can be represented as a multiple of 3 can be represented as 3k. And 3k plus 1, 3k plus 2 are not multiples of 3. And if we consider 3k plus 1, 3k plus 2, we cover all possible integers. So if n is not a multiple of 3, it can be represented as n is 3k plus 1 and 3k plus 2. And let's consider n squared, it becomes 3k plus 1 squared is 9k squared plus 6k plus 1, and it's can be represented as 3k squared plus 2k plus 1, and it's a multiple of 3 plus 1 is not a multiple of 3. And if we consider 3k plus 2, n squared is 3k plus 2 squared is 9k squared plus 12k plus 4, and it's 3k squared plus 4k plus 1, and again it's a multiple of 3 plus 1 is not a multiple of 3. So it contradicts the assumption that if n is not a multiple of 3, n squared is a multiple of 3. And hence the statement that if n squared is a multiple of 3, n is a multiple of 3 is proven by contradiction. B. Hence prove by contradiction that square root of 3 is an irrational number. And again, assumption is that a square root of 3 is a rational number, and since it's a rational, it can be represented as a over b, and it's very important that a and b are some integers so that they have no common factors, and it means that this fraction a over b is not reducible. And then we square both sides and get that 3 is a squared over b squared, and a squared is 3b squared. And we can see that a squared is a multiple of 3, and using the previous result, it implies that a is a multiple multiple of 3, and since it's a multiple of 3, it can be represented as 3m, for example, and it becomes 3m squared is 3b squared, this expression, and it becomes 9m squared is 3b squared, so b squared is 3m squared, so b squared is a multiple of 3, hence b is a multiple of 3 and can be represented, for example, as 3c. Hence a over b becomes 3m over 3c, and now a and b have a common factor which contradicts the assumption that they have no common factors, and hence our assumption is not true. So the initial statement is true. It is proven by contradiction. So a square root of 3 is an irrational number. And that's all for this question.